The last section of Chapter 4 is dealing with overlapping triangles. So here's my first example. It looks kind of weird when you're just looking at it, so you may consider to draw it out. So ACD is what I overlined in purple, and then noticing that I have BEC over here. So notice that the side that they the angle that they share is angle C. So you may consider to write them separate. So I put the purple one over here on the left for you to see, and I put the green one over here on the right, which some students last year found that to be helpful. Some of them didn't. So whenever you are looking at overlapping triangles, they either have a side that they have in common or they have an angle. And this doesn't have a side because from the purple to the green here doesn't match up all the way. Same thing here. If I was going from the green to the purple, it doesn't match up. But I do see this angle right here that they have in common. So that's why I put angle BCD as an option to put for that angle. I'd like for you to pause the video and try the got it question. So in the got it question, it's asking what is the common side in triangle ABD and DCA. So ABD is this triangle here, and then I have triangle DCA, which is over here. Noticing that the side they have where the colors overlap is angle or side DA or AD, depending on how you wrote it. The next question asks what's the common side of ABD and BAC. So if I keep my green triangle and excuse me, and do BAC, notice that my green and my pink overlap at side BA. So sometimes it helps to use those colors. Sometimes people like to separate them out and see what letters they have in common. Some of them can just see it from looking at the two triangles and see the wording. So noticing that I have AB in both of those, so that's how I know it would be BA. Or I have DA in common both there, so that would be DA. We're going to run through a couple proofs dealing with overlapping triangles, and some of them get pretty involved. So I just want to make sure you know what it would look like, not necessarily expecting you to do a full proof like that by yourself. It would be probably more guided where you would just have to fill in some of the blanks. So let's take a look at this first one. It shows that I have triangles or angles ZXW congruent to Y WX, so I separated them out so you can see it, and then I went ahead and put in one tick or one arc on both of them. And then I have ZWX and YXW congruent, so I marked it with two arcs. So then the next thing is, in my proof, after writing down my given, there's always a side or an angle that an overlapping triangle should have in common. Well, they both have WX in common, so my next step was putting WX is congruent to WX, and again by the reflexive property. Now notice that my triangles are congruent to each other by angle side angle, so that was the next step that I wrote down, those two triangles congruent to each other. And then last, I'm trying to show that ZW is congruent to YX, and those are corresponding parts, so I can write down those are congruent by CPCTC. So that one is not too bad as far as a proof goes, but then when you start looking at these ones that are on the back side, they're pretty involved, and it's only a lot involved just because of the fact of what the picture looks like. So just bear with me, try and run through them with me, try and make sure it makes sense. I just want to expose you to it just so you can see what it would look like. I do not expect you to be able to do that whole proof by yourself. I would expect you to be able to fill in some of the blanks. Okay, so I write down my given. They tell us that PS is congruent to RS, which they've marked, and then they give me the PSQ and the RSQ are also congruent, and they've marked that. So that's the first thing I'm looking for. Next thing is I'm trying to show QPT and QRT, those triangles are congruent. So I'm just going to start throwing out things that I know are congruent. And the first thing I know is SQ has to be congruent to itself, and that's because of the reflexive property. So I'm breaking this down into this big triangle here by itself, so that's why I was writing this out over here so you can see it. So kind of ignore all of those other marks. The next thing, as soon as I wrote it out as just two triangles left and right, I saw that I had side angle side. So I went ahead and said those big triangles on the left and the right are congruent to each other by side angle side. Then the next thing is, do I know any other corresponding parts within those that could help me out? And yes, so now I'm going up here to this picture and putting PQ has to be congruent to QR because of CPCTC, since I just proved that these two big triangles are congruent to each other. Then the next step is QT has to be congruent to itself because of the reflexive property. So now I'm in here inside of these two small triangles. And then I automatically, or I put angle PQS and SQR are congruent to each other by CPCTC because those are the big parts of the angles. So they are here, and then if you wanted to draw them up here, they are. And so then last, I said, well then these two smaller triangles have to be congruent to each other by side angle side. So notice there's a lot of steps in there. You need to take some time to process it because I explained it very fast, but that's because I've already went through it myself. So when you're doing a proof, you just want to start throwing out stuff that you know and then see if you can work your way in to find those smaller triangles. I want to expose you to one more proof. So take a look at this one that's on the bottom here. So I wrote down my given. CA is congruent to CE, and then I also know that BA is congruent to DE. And I went ahead and took out these smaller triangles so that I could see what's congruent, because sometimes it's hard to see it inside there. So the next thing I said was AE is congruent to itself because it's overlapping. So I said that by reflexive.
Madison Briggs, Gloria Bailey, and Emma Whaler to the office, please.
Then I also said that BAE has to be congruent to PEA because those are the base angles of the big triangle. Since they gave me that CA is congruent to CE, that's isosceles, so that's how I knew those base angles are congruent. And so then, after I wrote that, then I could say, oh yeah, side angle side, those small triangles are now congruent to each other. So then continuing, I put ABE, that angle is congruent to EDA over here, so that's by CPCTC. And then I also know that BXA and DXE are congruent by vertical angles. So just starting to throw things out that you know that are congruent. So then last, I put that these two small triangles are congruent to each other by angle, angle, side. And then to finish, I put BX congruent to DX by CPCTC. And I'm giggling only because I know some of you are like, oh my goodness, this is so long, I'm not going to ever understand this. Again, I would not expect you to be able to do a full proof like that. That is very challenging and pretty in-depth. But I would expect for you to try and follow the pieces. So if I guided you and gave you one of these, could you tell me why they'd be congruent? Or if I said that CPCTC was the reason, could you give me the statement over here? So that's what I mean by that guided proof and trying to make sure that you could still follow along with it.
Madison Briggs to the office, please.
So last piece, overlapping triangles, remember that there's always a side or an angle that should be congruent to each other. So when you have overlapping triangles, try and locate that first.